Hello and welcome to G Fun Facts Online, the show that unpacks the incredible science and technology shaping our world. Today, we're talking about a race. But forget the Cold War, forget competing flags and national prestige. The new space race is here, and it's being fought in boardrooms and on launch pads by entrepreneurs, startups, and private companies. It's a race to build a new economy, a new frontier, not just for exploration, but for business. We're moving from planting flags to building factories in the final frontier. So buckle up, because we're about to launch into the era of commercial spaceflight. And it's happening faster than anyone ever imagined. The single biggest reason we're even having this conversation is a revolutionary idea. What if a rocket wasn't a disposable, single-use item? For decades, spaceflight was unbelievably expensive. For a simple reason. Imagine buying a brand new Boeing 747, flying it from New York to London once, and then pushing it into the Atlantic Ocean. That's exactly what we did with rockets. We'd spend hundreds of millions of dollars on a magnificent machine, only to have it burn up in the atmosphere or crash into the sea after a single flight. It was the ultimate barrier to entry. But then, companies like SpaceX and Blue Origin came along and ask a different question. What if we could land the rocket and use it again? This is the reusable rocket revolution, and it has fundamentally changed the economics of space. SpaceX, led by Elon Musk, has truly mastered this. You've probably seen the videos. A towering Falcon 9 booster, after launching its payload towards orbit, gracefully descends back to Earth, firing its engines for a pinpoint landing on a drone ship in the middle of the ocean. It looks like science fiction, but it has become routine. The Falcon 9 has launched and landed hundreds of times, making it the workhorse of the global launch industry. By reusing the most expensive part of the rocket, the first stage booster, SpaceX slashed the cost of reaching orbit by an order of magnitude. They're not stopping there. Their next project, Starship, is a behemoth. It's a fully reusable spacecraft, meaning both the booster and the spaceship itself are designed to return to Earth and fly again and again. Starship is designed for missions to the Moon, Mars, and beyond, capable of carrying 100 tons of cargo or 100 people at a time. This isn't just an incremental improvement, it's a quantum leap intended to make humanity a multi-planetary species. And this isn't a one-company show. Jeff Bezos' Blue Origin is another major player. Their New Shepard rocket is already taking tourists on short trips to the edge of space, and its rocket booster is also reusable. They are also developing a massive orbital rocket called New Glenn, which will also feature a reusable first stage, designed to compete directly with SpaceX's Falcon Heavy. Across the globe, the race is on. The European Space Agency and various startups in China are all aggressively developing their own reusable rocket technologies. Everyone knows that reusability is the key to the future. The impact goes far beyond just saving money. Cheaper launches mean more frequent launches. This allows for the rapid deployment of massive projects, like satellite mega-constellations that provide internet to remote corners of the world. It accelerates innovation because you can test new ideas in space more quickly and affordably. And there's an environmental benefit too. Reusing rockets means less manufacturing and less high-tech debris being discarded in our oceans or atmosphere after every single launch. The rocket revolution has unlocked the door to space. So the next logical question is, now that we can get there cheaply, where are we going to stay? For over 2 decades, the answer has been the International Space Station, or ISS. The ISS is one of humanity's greatest engineering achievements, a symbol of international cooperation, and a vital laboratory in the sky. But this magnificent outpost is aging. It's expected to be decommissioned and deorbited around 2030. So, what comes next? Will we abandon low Earth orbit? Absolutely not. A new generation of commercial space stations is emerging to take its place. Think of them as privately owned and operated business parks, hotels, and research labs in orbit. At the forefront is a company called Axiom Space. Their plan is brilliant. They are building commercial modules that will first attach to the International Space Station, like adding a new wing to an old house. Astronauts will live and work in these modules, which will be financed by a mix of private research, in-space manufacturing, and even tourism. Then, when the ISS is ready for retirement, the Axiom modules will detach and become their own free-flying, independent commercial space station. It's a seamless transition from the old era to the new, but other companies are trying even more futuristic designs. Sierra Space is developing an inflatable habitat called the Life Module, which stands for Large Integrated Flexible Environment. Don't think of a simple balloon. This module is made of Vectron, a fabric that, when inflated in space, is stronger than steel. The advantage is that you can launch a huge habitat packed down into a small rocket fairing. Once in orbit, it inflates to offer a massive, comfortable living and working space for astronauts. One launch can create a habitat the size of a 3-story apartment building. Then there's VAST, a company with the audacious goal of launching the first ever commercial space station, called Haven 1, as early as 2025. It will be a smaller, single-module station to start, but they plan to follow up with a larger, spinning station that would generate artificial gravity. These commercial stations are absolutely crucial for our future in space. They will be the laboratories where we conduct the microgravity research needed to develop new medicines and materials. They will be testbeds for the life support systems and technologies we need to survive long-duration missions to Mars. And yes, they will be the first true hotels in space, destinations for a new wave of private astronauts and tourists. The hardware, the rockets, and the habitats is impressive, but none of it would work without the brains of the operation. And in the 21st century, the brains are made of silicon and code. The new space race is being powered by sophisticated software and, increasingly, by artificial intelligence. AI is playing a critical role in every phase of a space mission, from the drawing board to deep space exploration. One of the biggest challenges in space is communication delay. When you send a command to a rover on Mars, it can take up to 20 minutes for the signal to get there, and another 20 minutes to see if it worked. You can't joystick a robot in real time from half a planet away. That's where autonomous systems come in. The AI that lands a SpaceX Falcon 9 booster isn't being controlled from the ground. The onboard computer is analyzing thousands of data points per second: altitude, velocity, wind shear, engine performance, and making its own decisions to guide the rocket to a safe landing. It's a beautiful example of AI in action. Another is SpaceX's Starlink satellite constellation. With tens of thousands of satellites planned, manually preventing collisions would be impossible. So an AI-driven system autonomously tracks every satellite and piece of debris, calculating collision risks and automatically adjusting orbits to keep the network safe. AI is also the ultimate mission planner. Before a probe is ever launched to Jupiter or Saturn, AI algorithms can simulate billions of possible trajectories to find the one that uses the least amount of fuel and takes the least amount of time. A cosmic-scale game of connect the dots, using the gravity of planets to slingshot the spacecraft on its way. Then there's the data. Our space telescopes and Earth-observing satellites are generating an unimaginable torrent of information every single day. No team of humans could ever sift through it all. AI and machine learning algorithms are our essential tools for this. They scan telescope data to identify the faint dip in a star's light that signifies an exoplanet passing in front of it. They analyze satellite imagery to monitor deforestation, track melting ice caps, and predict crop yields. And of course, AI is the mind inside our robotic explorers. Rovers on Mars, like Perseverance and Curiosity, are not remote-controlled cars. They are AI-powered mobile geologists. They can navigate treacherous terrain on their own, identify interesting rocks with their cameras, and decide to zap them with a laser to analyze their composition, all without waiting for instructions from Earth. With cheaper access thanks to reusable rockets, permanent addresses in orbit thanks to commercial stations, and smart robotic brains thanks to AI, space is transforming from a place we visit to a place we work. The next frontier is industry, and two sectors are poised to create a genuine gold rush in the sky: in-space manufacturing and asteroid mining. In-space manufacturing, sometimes called orbital manufacturing, is exactly what it sounds like: making things in space, for use in space. The key is the unique environment of microgravity. Here on Earth, gravity affects everything we make. It causes materials to settle, it introduces defects into crystals. But in the weightlessness of orbit, you can create things that are impossible to make on the ground. For example, you can grow perfectly uniform protein crystals for drug development, or manufacture fiber optic cables that are orders of magnitude more efficient than anything made on Earth. The primary tool for this is 3D printing. Imagine you're an astronaut on Mars and a critical component on your habitat breaks. Do you wait 2 years for a replacement part to arrive from Earth? No, you just download the blueprint and 3D print a new one. This ability to manufacture on demand will be essential for long-term space exploration, reducing our dependence on an Earth-based supply chain. Even more ambitious is the concept of asteroid mining. For a long time, this was pure science fiction, but now it's a serious business prospect. Asteroids are the leftovers from the formation of our solar system, and they are flying treasure chests. They are rich in valuable resources that are either rare on Earth or incredibly expensive to launch from Earth. We're talking about platinum group metals, which are vital for electronics. But the most valuable resource in space might be the simplest: water. Water, frozen as ice in asteroids, can be mined and then split into hydrogen and oxygen. What do you get when you combine hydrogen and oxygen? Rocket fuel. Asteroids could become the gas stations of the solar system, allowing spacecraft to refuel in orbit for missions to the outer planets. The metals could be used for in-space construction, building habitats and ships using materials already in space. While the technology for robotic mining is still in its early stages, companies are actively designing probes and extraction techniques to make it a reality. But as we get busier up there, as we launch more satellites and plan more ambitious projects, we're creating a new and dangerous problem: space junk. For over 60 years, we've been leaving debris in orbit: spent rocket stages, dead satellites, even flecks of paint from old missions. There are millions of pieces of debris orbiting Earth, traveling at speeds over 17,000 miles per hour. At that velocity, even a tiny screw has the impact energy of a hand grenade. This creates a risk for a catastrophic chain reaction known as the Kessler syndrome. One collision creates more debris, which then causes more collisions, creating even more debris, until low Earth orbit becomes so cluttered that it's unusable for generations. Thankfully, the same private industry that is driving this new age of access is also pioneering the solutions for sustainability. A new market is emerging for what's called active debris removal. Companies like the Swiss startup ClearSpace and the Japanese company Astroscale are developing what are essentially space garbage trucks. They are designing spacecraft that can rendezvous with a piece of debris, capture it with a robotic arm or a net, and then drag it down to burn up harmlessly in the atmosphere. Another key area is in-orbit servicing. Instead of launching a new satellite when an old one runs out of fuel or has a minor malfunction, we could send a robotic mechanic. These servicing vehicles could dock with a satellite, refuel it, repair it, or even upgrade its components, dramatically extending its lifespan and reducing the need to launch replacements. It's the ultimate form of recycling. This also extends to how we design satellites in the first place, with modular components that are easy to repair and standard docking ports for refueling. By actively addressing the challenge of orbital sustainability, the private space industry is protecting its own valuable assets while ensuring that space remains a safe and accessible resource for everyone. So where does this all lead? We are standing at the very beginning of a new chapter in human history. The convergence of reusable rockets, commercial space stations, advanced AI, and the promise of in-space industry is creating a powerful feedback loop. Each breakthrough enables the next. Cheaper access allows for more ambitious habitats. Smarter robots make asteroid mining feasible. In-space resources will fuel deeper exploration. This is no longer just about sending a few highly trained astronauts on short missions. This is about building a permanent, self-sustaining and thriving human presence beyond Earth. A future with floating laboratories, orbital factories, interplanetary gas stations, and Martian cities. The final frontier is officially open for business. Thanks for tuning in to G Fun Facts Online. Join us next time as we explore another amazing corner of our universe.